So I'm going to talk about calorimetry today. We talked about calories yesterday and what calories were, how many they were as far as joules were concerned, and that sort of thing. So you're going to come in on either tomorrow if you're A day or B day on Friday, and you're going to be doing a lab using calorimetry. A calorimeter is an insulated device, and it uses the amount of heat that's either absorbed or released in a reaction. Okay. So when you read the calorie content on your various food items and that sort of thing, this is how they've gotten it. They essentially put the food in one of these calorimeters, they burned it, and they measured how much heat it gave off. Okay. This is the way they work. You generally will have inside here, you're going to have whatever item it is that you're trying to burn or heat, or it's going to be releasing heat. In the case of food, they put the food in here, and then they'd ignite that. There would be some oxygen in here, and then they would have water outside this sealed area. So this would be closed. They're just opening it up for you to be able to view here. Out here, they would have that in water, and whatever heat is released from this food into the water, the temperature of the water will go up, and they measure that temperature, and that's how much heat was released by the food. So that's how they get the calorie content. This is our calorimeter here at Craig High School. It is 2 styrofoam cups and a styrofoam lid with a temperature probe stuck down inside it. Okay. This is like, I don't know, $3,000. This is like 20 cents. Okay. I know it seems crude, but we actually get halfway decent data from this. Would it be good enough to, use for scientific purposes? No, but for a simple lab, for the expense of the equipment that this is, it actually turns out pretty well. So what you're going to do is you're going to take samples of metal and you're going to put them in a beaker of boiling water, and you're letting them boil for a few minutes. And by boiling them, then if they're in boiling water, the temperature of the boiling water is 100 degrees. You take that metal then and you put it into this water and then see how much the temperature goes up. And then that's how much heat that metal has given off. And then you can figure out the specific heat from that. Okay. So here's our problem. We've got a piece of metal. It has a certain mass associated with it. This is going to let me draw in here. Yes. Okay. It has a mass with it, and it's going to absorb this much heat. Its temperature increased by this much. So this is your delta T. They wanted the specific heat of the metal. And then we have slide 9 here. Hold on a second, guys. Oh, this is the bank. Hold on. Hi, is this Crystal? Hi, fine. Okay. Yeah. Okay. Okay. No, it's fine. I've got it right here still. Okay. Oh. Can I just scan it and email it to you? Do I have to bring it by today, or can Brian bring it by next time he does a deposit? Okay. Okay. And then we don't get the fee, right? We won't get the $20 fee. Oh. Oh, well, I don't understand why it accepted the image and then we get a fee on top of it. Why did it accept the image then? That's not really fair. But it did in the app. So it told me that it was fine in the app, and it said that the deposit was fine. So why do I get, I don't understand why I get a fee. Okay, I don't think that's fair. So, okay, but it doesn't matter what I think. So, okay, I'll have Brian bring it by to you. Okay, all right, so is that, where was slide 9 on here? This was, oh, here. Okay, so we're trying to match up the specific heat on this slide, which I think you guys have this, that diagram in your thing. Okay, so if we had our Q yesterday equals CM delta T, okay, we have our specific heat is what we're solving for. We need to get this guy by himself. So C is going to equal Q over M delta T. Our Q is how much heat it absorbed, which would be 256 joules. Our mass was 4.68, and we're going to multiply that by 182. And when we do that, we get 256 divided by 4.68 times 182 and parentheses equals. I ended up with 0.301, and my units would be joules per grams degrees Celsius. So we're going to try to find, it says a metal here, and they wanted an alkali earth metal that came in at this specific heat. So 0.301, oh, right there, strontium. That would qualify. So we would be able to identify that metal as strontium. Okay? So that's how we do those problems. Good?
Okay, so basically the objective of the problem is to figure out what the metal is?
For this problem, yeah.
Okay. So then the answer would literally just be the name of the metal.
Well, it says, what is the specific heat? So that's the first question. And then could the metal be one of them on that slide? And the answer to that part of the question would be yes, it would be strontium.
Oh.
So it's a two-parter.
Oh,
okay. Okay? So tomorrow, that's what you're going to essentially be doing is looking at the water that's being released, or the heat that's being released